So in this video, I'm going to talk to you about how to prepare for the Visual Sentence Reactions with LR quiz. This is a critical quiz in improving your grade at this point in the semester, so I really wanted to make sure that you're spending your time mastering this quiz so you can improve your grade. So first, you got to know three basic definitions. You got to know what an atom is, what a molecule is, what a compound is. So these last two definitions are accurate, yet there's more to it. We're going to learn that in the next section. So first, an atom is a single unbonded atom that's by itself. That's what we use when we say the word atom. A molecule is two of the same atom bonded together, and a compound is two or more different atoms bonded together. When we use these three words to define different kinds of particles, then you can write a sentence describing a chemical reaction. So, in this sample problem, you can see that there's a chemical reaction at the top, which is balanced, and you can see that I've written the words that are the names of each of these particles below it. And you'll see something very similar on the quiz. So, the first thing you have to do is be able to write a sentence. So you can write one propane compound reacts with 5 oxygen molecules to make 3 carbon dioxide compounds to make 4 water compounds. Now the reason you can call propane a compound is because the atoms are different from each other. The reason why you can call oxygen a molecule is because the atoms are the same. You can call carbon dioxide a compound because the atoms are different from each other. And you can call water a compound because the atoms are different from each other. Again, these definitions aren't perfect, but they're good for right now. Okay, so the next thing you do after you write this sentence down is you got to match the compounds on the left side here to the reactants, the left side of the chemical reaction. So you can see that these two gray circles match up to the oxygen. So these little gray circles are oxygen. And you can see that this has 3 black circles and 8 white circles. So we know that this is C3H8. So then you got to figure out, okay, how can I figure out how many times I'm going to run the reaction? So basically what this is saying is it's saying that one C3H8 and 5 O2s make the reaction run once. So that's what we're going to try to figure out is how many of those combinations exist in this example. So you can see here that it happens once. And I can see it happening again. So this reaction runs twice because I have 2 C3H8s and 10 O2s at the very least. Notice I don't have enough to be able to run this again. So I'm not going to circle anymore. So then we have to draw our result. So if I run the reaction once, I have 1 C3H8 and 5 O2s. You can see here that I would make 3 CO2s and 4 H2Os. But since I'm going to run the reaction twice, I circled twice here, I'm going to make 6 O2s and 8 H2Os. So that's what I'm going to draw over here. So the reason I can draw it like this is because I learned from this drawing over here that the carbons are black. So there's 1 C. And I learned that the oxygens are gray. So I can draw 2 of those here. Okay, so that's my CO2s. Now I'm going to draw the H2Os. So those are my H2Os. Forgive me for my poor drawing there. And then I have to draw the leftovers. You can see that these are the leftovers from the chemical reaction because the reaction couldn't run any more times. So I'm going to draw those. And that's the result of this chemical reaction. 6 CO2s, 8 H2Os, 2 O2s left over, and 1 C3H8. So you can see here that the limiting reactant was the oxygen because I had enough C3H8 to do this more, but I didn't have enough O2s. So I know that my O2 is my limiting reactant and my C3H8 is my excess. Now there's a mathematical way to do this, and the way you do this is you count how many O2s you have. So I'll write it here in the middle. I have 12 O2s and I divide by 5, right? Because that's the amount that I need. I take what I have and divide by what I need. And then the C3H8, there's 3 of them. I have 3, but I only need 1. Remember up here, the coefficients on the chemical reaction are what we need. So we can see that this number here, 12 divided by 5, is less than the 3 divided by 1. So I know that where that number comes from, the oxygen, is the limiting reactant, and the other one is the excess. So you can see this in this document that I've done this digitally. So let's try another prompt. So again, it's the same reaction at the top. So then all we're going to do here is count. So let's do the math part first. We see that there's 2 C3H8s. So we're going to do 2 divided by 1. And then I'm going to count my O2s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we can see here that it's 11 divided by 5. And we can see that 2 divided by 1 is less than 11 divided by 5. So we know that C3H8 is our limiting reactant and the excess is our oxygen. So now we can do our circling to figure out how many times the reaction runs. We know that it runs twice from the math, but I wanted to show it to you in a non-math way. So I circle that and I circle that, and I'm going to run it twice. And so you can see that's going to make 6 CO2s. We're going to run the reaction twice, and 8 H2Os. And I could draw that for you, and you can watch me do it, or you can just take a look at the next slide. So go ahead and pause the video right here, write the sentence, figure out what the LR is, what the excess is, and do the drawing. Okay, so now that you've had a chance to try it on your own, let's do it here. So you can see here that would be 4 sodium atoms, right? Na is by itself, reacts with 1 oxygen molecule to form 2 sodium oxide compounds. Okay, so now we have to do our math to make sure that we understand what the LR is and what the excess is. So it's 4 is on the bottom of the fraction because that's what we need. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sodium atoms, that's these black circles because they're by themselves. And then we're going to count the oxygens, which are 4. And we only need 1, right? There's a 1 in front uh, as the coefficient in front of the oxygen. So we know that this number is lower. So we know that that is the limiting reactant. That's the one that runs out first. So we put oxygen as our excess reactant. So now we're going to do our circling to figure out how many times we're going to run the reaction. We see we run it once, and we're seeing that running it twice. So now we do the drawing. Since we're going to run the reaction twice, we're going to make 4 Na2Os. It says to make 2, but since we have run the reaction twice, we're going to multiply everything on the product side by 2. And those are our products. And now we have to draw the leftovers. We can see that we have 2 oxygen molecules left over. And you can also see that we have 1 sodium atom left, which you can also see on the next page in digital form. Okay, so same reaction, but different set of givens. So go ahead and pause the video here and try to figure out what the limiting reactant is and what the excess reactant is. Okay, so let's do the math. So you can see here that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 NAs. So it's 11 divided by 4. And oxygens, there's 1, 2, 3, 4, 5, 6, 7, 8. 8 divided by 1. So obviously, 11 divided by 4 is less than 8 divided by 1. So the limiting reactant is Na, and the excess reactant is O2. Now we're going to do our circling. So it's always 4 NAs for 1 O2. So run the reaction once and twice. And I can't run it anymore because I don't have 4 NAs. The ratio always has to be maintained. So I'm going to run the reaction twice. That means we're going to make 4 Na2Os. And then we're going to draw our leftovers, and you can see we have 6 oxygen molecules. Remember, we're counting molecules, not atoms. There's our 6 oxygen molecules, and you can see that we have 3 sodiums left over as well. We'll draw those in. And that matches what's on the next screen. Right there. And for this next sample problem, go ahead and try writing out the sentence. Okay, so we notice we have 6 potassium atoms, reacts with 1 boron oxide compound to form 3 potassium oxide compounds to form 2 boron atoms. Okay, so now try to figure out what the LR and the XS is by doing the math. So we count the number of Ks, and so we see potassiums are these black circles. 3, 6, 9, 12. So it's 12 divided by 6. And the B2O3s are these gray and white circle compounds, and there's 3 of those. So it's 3 divided by 1. We can see that 12 divided by 6 is lower than 3 divided by 1. So we can figure out that that is the limiting reactant in B2O3. is the excess. So now do the drawings. Pause the video. So you can see that we have to circle. So we're going to circle 6 Ks, and we're going to circle 1 B203. And let's see if we can do that again. You can. So we're going to run the reaction twice, which means you're going to make 6 Ks, K2Os, and 4 Bs. So I'm going to draw the 4 Bs first, because that's going to be easier. And then I'm going to draw my 6 K2Os. And then we draw our leftovers. When you do the drawings, make sure the atoms in the same particle are touching each other. And that can be seen on our next slide here. And for our last example, it's the same reaction, but different given. So go ahead and try this one on your own before watching the rest of the video. So we're going to do the math first. We can see that there's 1, 2, 3, 4, 5, 6, 7, 8. 8K, so it's 8 divided by 6. Have divided by need. And we can see we have 1, 2, 4, 5 B203s. We can see that this number is definitely lower than 5 divided by 1. So we know that's the limiting reactant. And B203 is the excess reactant. Then we're going to circle to figure out how much products we make. And we see here that we can do the reaction once because we've run out of Ks. We don't have enough Ks. So we're going to draw 3 K2Os and 2 Bs. So first I drew the 2 Bs, and now I'm going to draw the K2Os. And there you go. But you have to make sure you're drawing your leftovers as well. So I'm going to draw these B203s that are left over. And then we have the 2 Ks left over as well, which are right here. Okay, and you can see that on the next slide. So I hope that helps you write the sentence, figure out what is the limiting and excess reactant, and then draw the pictures. If you have any questions, please ask. Thanks and best of luck. Bye.